So children have finished. They've got an answer. We know what we want to do is really draw out the reasoning. So they've not just engaged in a problem-solving task, but they've learnt about what it means to problem solve, to break that task down, and they're able to reason, identify some of those key things that they actually did to help them problem solve in the future. A previous video, we looked at how to introduce this task, where we position counters to make the sums of the columns and the rows correct. I've seen children stumble on the answer to this, but not really be able to reason as to what they've done and help them to solve a future problem. So we can look at the different approaches. And one thing I'd often say is, what's a good starting point? Or where do we know there must be counters? And so we're trying to emphasize that there must be 3 here. And then we can look at, well, where could or couldn't counters go from there? And so when we explore this, we can then develop the reasoning in terms of, well, which counters will have to stay where they are when we're trying to find another answer. And that helps us to draw out the reasoning in this task. As we can see here, here's another answer. So similarly, this is another problem-solving task. In the previous video, we looked at how do we break down the barriers so children can access it. And think, well, what actually is the reasoning here? We can compare the different approaches. What are the different starting points that children went to? Did they think, I've got to think of 4 numbers that add to make 23 first and explore? And we can think, what's the most efficient starting point? Now, it could be we focus on the difference between the smallest and the largest number 6. And so we could think, well, what could those numbers be? Let's say there were 1 and 7. Would that work? Well, then the third largest number would have to be 6. Well, that doesn't quite work then, because then our largest number, the difference between the largest and the smallest number, wouldn't be 6 anymore. And that shows this potential strategy for this kind of question. What's a good starting point? And then we could focus on then we might try 2 as our smallest number, 8 as our largest number. Think, does that work? And then what could I try next if I make my third number less than 8? If I tried a 7, then I've found one possible answer. And then I could go from there. Well, what might I try next? Edging towards what are all the different answers that could be found, but really drawing out then the reasoning here. So the explain task in this IC problem solving task is explain how you know that this statement is correct. The largest number must be more than 7. So the explain task, really try and draw out the reasoning from that main task. Another example then would be another IC problem solving task would be the main task is positioning the digits to complete the number sentence. The explain task, again, draws on an element of the reasoning from that problem solving task. So 29 plus 7 equals 36. You can move 2 of these digits to make a new number sentence. And so that leans on one of the aspects of the reasoning from engaging in the problem-solving task. But so important that we draw out the reasoning. So it's not just children engaging in problem-solving, but really thinking about aspects of the strategy so that will really enhance their ability to solve future problems as well.